Greetings once again. The previous video I put up talked about the ambiguous case when we have the two sides in the non-included angle, what we call the ambiguous case. And I finished that video with this screen right here, kind of talking about the different possibilities. So sometimes we may not have a triangle possible, depending on the length of the opposite side. Sometimes we might have just one triangle possible if the opposite side is larger than the adjacent side. And sometimes there's two triangles possible if the opposite side is less than the adjacent but longer than the minimum. So there's going to be a link to that previous video talking about when those situations happen and how to determine that. There'll be a link in the description at the end of this video. And if you haven't watched that yet, please watch that first, because all I'm going to do here is run through the actual examples of how to do those and kind of what each case looks like. Okay, so we're going to jump right in here. I've got a few different examples to go, and then there's going to be one at the end where you can pause the video and try one on your own, and then just see the answers immediately thereafter. So here we go. Here's the first example. So angle A 50 degrees, side A 15, side C 12. So if we sketch that thing, the thing to notice here is my opposite side is greater than the adjacent side, so we're going to use the law of sines, and nothing too crazy is going to happen here. And so this is kind of what the triangle is going to look like. So we see the 50-degree angle, opposite side 15, adjacent side is 12. So we need to find all of these other things here. So I'm going to find angle C first with the law of sines. And then we're going to find, my B disappeared up here. So we're going to find angle B just by subtraction, and then we can find side B with the law of sines also. Okay, so here we go. Here's the math. And what I'm going to do, I'm going to set up the equations and kind of see how the equations themselves work. And then after each problem, I'll bring up the calculator part of it and show you what the answers are, so you can kind of see that end of it. But I'm going to try to streamline this as much as possible. So to get angle C, so notice we know the whole A pair, right? So we know that sine 50 is to 15 as sine of C is to 12. Okay, now we're going to do the cross multiply and divide thing. And so if we do that, we know that 15 sine C equals 12 sine 50. And then solving this for C, and I'm going to do this in one step. So angle C is going to be equal to the inverse sine of 12 sine 50 divided by 15. Okay, now if you need to pause the video and kind of let that percolate for a second, please do. But notice I'm dividing by 15, and to get the angle, we need to do the inverse sine function. So that's going to be my angle C, okay, which you put in the calculator. Okay, and depending on the calculator you have, you may have to change that answer back into degrees, but that is going to come out to be 37.79 degrees. And again, I'm going to bring the calculator up at one time at the end of this problem, and I'll show you kind of how I typed all that stuff in. Once you find that, so that's all well and good. That's angle C. So for my angle B, I know two angles now, so now it's just a subtraction problem. So 180 minus the sum of the two angles that I know. And that's going to come out to be 92.21 degrees. So I can scroll down here under my picture and pop those guys in there real fast. So angle C, 37.79. And angle B, 92.21. And now the only thing that's left to find now is my side B down here. And again, I'm going to do that just with a normal law of sines. And the way I'm going to set that up, again, I'm going to go back. I know my A pair, the sine 50 over 15. So I'm going to say that sine of 50 over 15 is equal to the sine of 92.21, which is the B angle I just found, over B. And this is just the normal cross multiply and divide. So B is going to be equal to 15 sine 92.21 all over sine of 50. And that will come out to be 19.57. All right, so if the opposite side you're given is greater than the adjacent, there's just one triangle, nothing crazy happens. Let me show you my calculator just to show you where all those numbers came from, so you know I'm not lying to you. So those are all the values. Notice on my top line, I have the radian values, so I had to multiply that by 180 over pi to get back to my degrees, but those are where all the values come from. Okay? So that's the easiest case where nothing, actually maybe not the easiest case, we'll see that in a second, but that's the case that's probably the most straightforward, I guess, is, you know, one triangle, you do the law of sines, and then off you go. Okay? So let's look at the next case. So now, these are the values I give you. Angle B, 25 degrees. Side B is 7 and side A is 20. And again, we know that this is the opposite side, right? So as soon as the opposite side is less than the adjacent side, then that means we need to run that test to see if that opposite side will even reach to make a triangle. Okay, and if you remember from the previous video and that kind of opening screen that I had at the beginning, to do that, we're going to take the minimum value, what we're going to call it. The minimum value is going to be 20 times the sine of 25 degrees. And if you do that, that's going to be equal to 8.45. Well, not good news, because what happens there, so we ran that test, and since my opposite side is 7, and that is less than 8.45, it is not going to reach. So we are basically done with the problem, because that's what the problem's going to look like. So I have no triangle. There's nothing I can do. If I had this on a homework assignment or even on a test, I'm going to put in great big letters, no triangle possible. And move on. Now, I would need to see this justification and something along the lines of, since B is less than 8.45, then no triangle possible. Okay, but that's it. So don't forget, anytime the opposite is less than the adjacent, we got to run that test to see if it's even going to reach. So you probably know what's coming now. So we did the kind of the easy case where opposite's greater than the adjacent, one triangle. We did the other kind of easy case where the opposite side doesn't even reach, so there's no triangle. So now we got the one that's kind of a pain. So here's the next one I'm going to do here. So I'm giving you angle C is 36, side C is 13, and side B is 18. And again, this is our opposite side here. So sure enough, opposite's less than the adjacent. So we need to check to see, is it going to reach? So we do that same thing, right? So the minimum value is going to be 18 times the sine of 36 degrees. And if you put that in your calculator, you will get 10.58. Which, that means it's okay. So the C value, that 13, so I'm going to write here, so since 13 is greater than 10.58, 13 is obviously less than 18, then there are two triangles possible. Okay? So again, run the test. If the minimum value is, if the opposite side is between the minimum value and the adjacent value, then we get two triangles, and we do need to find them both. Okay? Here's what the triangle is going to look like. So this is kind of what we have, right? And I'm going to be talking about as we go through this problem. So we're going to find the B1 value first. We're going to pretend like the angle B is acute and basically find this whole big triangle that we see here. And then we're going to find, so we'll find the angle B1, and then we're going to find the big angle A, what I'll call A1, and then we'll find the big side A, which I'll call A1. Once I get that triangle, then I've got to go in and find this little skinny triangle. So right here, and my B2 value right here, and then my little tiny A2 value. Okay, so that's going to be the process. We're going to find the big triangle first with B being acute. We'll find all of those values, get that completely solved out, and then we'll find the second triangle where B is obtuse. All right, so let's take a look and see how we're going to do that. So here's kind of just kind of a rough sketch of that big triangle that we have. So we just start using the law of sines, exactly what we just did. So I'm going to go and find angle B1, set up my law of sines, and that's going to be sine of 36 divided by 13 equals sine B over 18. Okay, this is just what I did on that first example. I'm not even going to set up the algebra. I'm just going to kind of set up what the final answer is going to be. So angle B, B1 I should say, B1 is going to be the inverse sine of 18 sine 36 divided by 13. And again, make sure we get our answer in degrees. Put that in your calculator and you should get 54.47 degrees. We find angle A1 just by subtraction. So we've got 180 minus 36 plus the 54.47. And so my angle A1 becomes 89.53. So I can fill those in real quick. And then side A becomes, the way you find that, again, normal law of sines. So sine 36 over 13 equals the sine of 89.53 divided by side A, call it A1. And again, that's going to lead us to A1 being 13 sine 89.53. Oops. Divided by sine 36, which comes out to be 22.12. Okay, so again, if you need to pause the video real quick and kind of make sure that you see where all those numbers come from, and make sure you're putting in the calculator correctly and that your answers match, I'll show you my calculator real quick, just on that solution. So those are all those numbers right there. And notice I am just rounding to the second decimal point. I know the AP standard is 3 decimal points, but I think for our purposes in this class, we'll be okay with 2. Okay. Now, we need to find the second triangle. Now, the good news is the second triangle is actually easier. There's actually less like trigonometry mathematics going on the second triangle. Because what happens is, remember, I'm going to go back to this previous slide here where all my pictures is. So remember, the law of sines, because of the way this inverse sine function works, it's always going to return that value in the first quadrant, right? So that's why we have that acute angle. To find the obtuse angle, all we got to do is take my B1 value that I just found and take 180 and minus that. Because remember, from your unit circle, the sine values in quadrant 1 and quadrant 2 are both positive, and they are supplementary angles. So if you remember, the sine of 30 degrees is 1/2, the sine of 150 is also 1/2, and that's going to convey on all of those angles in quadrants 1 and 2. So all we have to do to find the second angle, my B2 angle, is take B1 and subtract that from 180. Okay? So I go back to my B1 angle, and my B1 angle was 54.47. So I've got my B2, what I'm going to call it, is 180 minus 54.47. So that's going to be 125.53. And again, that's going to be that little fat angle right there. Okay, and angle A, I want to call it A2. Again, it's another subtraction problem. So now I've got, for the whole triangle, 180 minus 36. That's still my angle C, minus my 125.53 that I just found. And that's going to end up being 18.47. Okay, and that's that little skinny angle up here on top. And now all I have to find is my side A2, that little tiny side on the bottom there. And again, that's just the normal law of sines. We do have to do that again. So I'm going to go back to my original, what I'm given. I know that for angle C and side C, so sine of 36 over 13 is equal to the sine of 18.47 over side A, and that's going to be A2. And that's going to lead me to A2 is equal to 13 sine 18.47 over the sine 36. And that is going to be equal to 7.01. Okay, and that is your second side of that triangle. Okay, so once you find the first triangle, the good news is your second triangle involves just a lot of subtraction and then just one application of the law of sines. The bad news is if you don't find your angle B correctly in the first triangle, then your second triangle is kind of in bad shape already before you get going. But I'm sure that won't happen to you. I'm sure you'll be okay. So I'll show you my calculator one more time on that second triangle, just so you know I'm not lying to you. So again, just doing that basic subtraction and then the law of sines for that final side. Okay, take a deep breath. What I'm going to do now, I'm going to show you one last example for you to do on your own. So I'm giving you angle B, 38 degrees. Side B is 8, so again, that's your opposite side, and then side C is 10. So pause the video, please. Write that down and see if you can solve that triangle on your own. And I'm going to come back in about 10 seconds, and I'm going to just zip through the answers, not even going to write anything down. I'm going to zip through all the solutions and go from there. So go and pause the video, give yourself a few minutes, try to solve that thing all the way out. Okay, so hopefully by now you have gotten the solutions, and hopefully you've realized that this again is a two-triangle case. So, because as we go through here, B is less than C, so you got to run that minimum value test. The minimum value ends up becoming 6.16. So 2 triangles are possible. So we gotta run through the whole law of sines for, in this case, the angle C being acute. Find that whole triangle and then find the smaller triangle. Okay. So here we go. Here are, and again, these are straight up the solutions. You're welcome to pause the video for a few, if you need to, for a few seconds to see everything. But this is for the big triangle with C being acute. And then for the second triangle where C is obtuse, again, it's just a subtraction issue to find the next, the other C2 angle. And there's your solutions for the second triangle. Okay, so that is a rundown of all the different cases of the ambiguous case when you're using the law of sines given 2 sides and the not included angle. There should be some links on the screen right about now for, again, that previous video saying about the background of the law of the ambiguous case. And I'll also link to just a plain video on kind of a normal application of the law of sines when you have 2 angles on one side. Please don't forget to subscribe to my channel. I'll be doing many more videos on trigonometry and other things mathematical as we kind of keep on moving forward. And if you have questions, please feel free to leave a comment or drop me a message that way. Thank you again for watching. Hope you got some insight onto the ambiguous case. Have a great afternoon.